For over 60 years, we have been listening to the sky, pointing enormous ears at the stars, waiting for a single word from someone, anyone, out there. And for 60 years, the universe has given us the same answer: nothing. We call it the Great Silence, a cosmos with hundreds of billions of stars, older than our sun by billions of years, full of worlds, and not one confirmed whisper of intelligent life. The numbers say we should not be alone. The silence says otherwise. For decades, that silence has felt like a verdict. Maybe life is rare. Maybe it dies young. Maybe we really are the only ones awake in the dark. But a new study published in 2026 quietly suggested something far more unsettling than being alone. What if they are out there, calling, broadcasting, reaching for us, and the message is arriving at Earth already broken? What if we have not been alone? We have just been deaf. This is the story of the Great Silence, and the disturbing possibility that it was never silent at all. In 1950, over lunch, the physicist Enrico Fermi asked a simple question that has haunted science ever since. If the universe is this big, this old, this crowded with stars and planets, then where is everybody? The math is almost cruel. Billions of stars in our galaxy alone. Billions of galaxies beyond it. Worlds older than Earth by 1,000 million years. By every reasonable estimate, the sky should be crowded with voices. And yet, every time we listen, we hear only the hum of dead physics, spinning stars, cold gas, the background static of a universe that does not seem to be talking. We named that contradiction the Fermi paradox, and we have never solved it. We assumed the silence meant absence. The new research asks a harder question. What if it means interference? To understand what might be going wrong, you have to know what we're listening for. Out of all the noise of the cosmos, scientists hunt for one specific thing: a narrowband signal, an impossibly thin, pure tone, focused on a single frequency. Nature almost never makes a tone that clean. Stars don't, gas clouds don't. So a sharp, narrow spike standing out from the static would be a fingerprint of technology, a deliberate broadcast. That needle in the haystack is what 60 years of searching has been built to find. The whole strategy rests on one assumption: that a signal sent as a sharp, clean spike will still be a sharp, clean spike when it reaches us. For 60 years, almost no one questioned that. The 2026 study questioned it, and the answer it found may explain the entire Great Silence. Here is the problem the researchers uncovered. A radio signal leaving an alien world does not sail off into clean, empty space. First, it has to escape its own star system, and that space is anything but empty. Every star is surrounded by a storm: hot, turbulent plasma, violent winds of charged particles, blasts of energy erupting off the star's surface. The study's authors showed that this chaos grabs a clean, narrow signal and smears it, spreads it across a wider range of frequencies, drains its strength. So the sharp white spike a civilization transmits doesn't stay sharp. By the time it claws its way out of its home system, it has been stretched into something wide, faint and faded. A smeared ghost of the original message. And here is the gut punch. Our searches are built to find the needle, the sharp spike. We mostly ignore the wide, faint smear, which means a real signal could be arriving at Earth right now, and our instruments would file it away as noise. We may not be failing to receive their call. We may be receiving it and throwing it away. It gets worse and stranger. The researchers found this smearing effect is most violent around a specific kind of star: red dwarfs, small, cool, long-lived stars that also happen to be the most common stars in the entire galaxy, around 3 out of every 4 stars in the Milky Way. These same red dwarfs are prime real estate in the search for life. They live for trillions of years, giving biology endless time to begin. So if alien civilizations are out there, a huge fraction of them likely orbit exactly the kind of star that scrambles their signal worst. Read that back slowly. The most likely homes for life in our galaxy may also be the places whose signals we are least equipped to hear. We may have been pointing our ears at the right stars and listening in the wrong shape. Think about what that means for us. In 1977, we launched 2 small probes, Voyager 1 and 2, each carrying a golden record: greetings in 55 languages, music, the sound of a human heartbeat, a message in a bottle thrown into the cosmic ocean. We have always imagined that if anyone is out there, our signal might one day reach them clean and clear. But the same physics works in both directions. Our messages, too, must fight their way out through our sun's storms and arrive at distant ears already bent and broken. Two civilizations could be calling out across the dark, both broadcasting, both listening, and never once recognizing the other's voice. Not because no one is speaking, because space itself keeps rewriting the words. To be fair, this is one study, and it does not prove anyone is out there. The great silence still has darker possible answers. Maybe intelligent life truly is vanishingly rare. Maybe civilizations destroy themselves before they can speak. Maybe some choose silence on purpose, hiding in a dangerous universe. This research doesn't overturn those ideas. What it does is humbler and in a way heavier. It says, before we conclude the universe is empty, we should be certain we were listening correctly. And we just learned that for 60 years, we may not have been. The scientists aren't giving up. They're changing how they listen, designing new searches that look for the wide, smeared signal instead of only the sharp one, tuning our ears finally to the shape a message actually arrives in. Because the most haunting idea in this whole story isn't that the universe is empty, it's that it might be full of voices, full of signals, full of others asking the same question we are, and that we have simply never learned how to hear them. Somewhere out there, a signal may be passing through you right now, stretched thin, faded almost to nothing, carrying a message we were never quite ready to receive. The sky was never as quiet as we thought. The question was never, is anyone there? The question was always, are we truly listening? Tell me what you think below. This is only the first signal we chase.